Hi, I'm Spencer from Leaside Minute Physics.
And I'm Richard.
Why is he putting this thing on my chest?
Stay tuned to find out.
Sir Isaac Newton was an English physicist who lived in England in the 1600s and most famous for his 3 laws of motion. Newton's first law of motion is the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. In other words, objects have a tendency to resist change in motion, that all objects have this magical thing called inertia. But not all objects are treated equally when it comes to inertia. Here's a large brick and a small brick. The large brick has large mass, the small brick has a small mass. Both bricks have an acceleration of 0 and they aren't moving. Both have a velocity of 0 meters per second. As you can tell by the force diagrams for each brick, there are no forces acting upon the brick that would be moving it in either way, just the normal force and the force of gravity. The large brick has a large mass, and therefore it has large inertia. Comparatively, the small brick has a small mass, and that means small inertia. What this means is mass is proportional to inertia. So as you can tell by the force diagram from the large brick, a large force is needed to start moving it because it has a large inertia. And for the small brick, a smaller force is needed to start moving it compared to the large brick because it has a smaller inertia. As you can see, the force needed to start moving the large brick is bigger than the small brick because the bigger brick has more inertia because it has more mass.
The same is true with objects in motion. Larger objects with more inertia will take more unbalanced force to stop them or speed them up than small objects with less inertia. Assuming both cars in our example are traveling at the same speed of 100 meters per second, ignoring friction and have no acceleration, the large car will take more force to stop it than is needed in the small car. This is because it has more inertia. It is more resistive to change in motion. If we look at the force diagrams, this also demonstrates it because it takes more unbalanced force from the brick wall on the left, showing backwards, than it does on the larger car. Now, enough for boring physics. Let's put this law into action.
Hey Spencer.
Oh, hey Richie.
How you doing?
Pretty good.
I have a brilliant idea.
What's that?
I bet you
Yeah.
that if I grab this cinder block,
Okay.
and if I place it on your chest,
Yep.
and I can hit it with a hammer and you won't feel it.
Why is that, Richie?
Well, that's because of the law of inertia.
Oh, okay, let's put that to the test.
All right.
Okay, so now we're ready to test it out. I'm balancing a 45-pound cinder block on my chest, and it's about to get hit with a hammer. Am I crazy? Maybe a little, but I should be fine according to Newton's first law. Since this brick has a large mass, it also has lots of inertia, which means it will have a tendency to resist change in motion. In other words, it won't start to accelerate when hit with a hammer. It'll just stay still, hopefully. Ready? Let's test it. All right, ready? Let's test it.
You ready, Spencer?
Okay, Richie, go for it. Okay, well that definitely wasn't pleasant, but it proved our point.
Spencer, are you sure you didn't feel this?
But at least I'm okay. Looks like Newton didn't fail us after all.
Look at this. I broke the entire cinder block and you didn't feel a thing?
Must have been inertia.
Alright, so an object at rest stays in rest. Why? Because look, as seen in our previous demonstration, look at what happened, and Spencer didn't feel a thing. But what about an object in motion? Like we talked about earlier, inertia will not only cause an object at rest to stay at rest, but it also causes an object in motion to stay in motion. Let's test that out now. As you can see here, inertia came into play once again. When the cart came to an abrupt stop, I kept moving. This is because the cart was acted upon by an unbalanced force. But I wasn't. My body's inertia has the tendency to keep moving, which is exactly what you just saw.
Well, that's all, folks.
We hope you learned a lot about inertia
And learned some new things.
and laughed at us along the way.
So we'd like to thank you for watching this episode of
Leaside Minute Physics, and hope you come back next time. Oh, hang on there. Hang on, come here. I want to show you something. Hey, Spencer! Spencer, get over here.
They're coming.
Hey,
I thought we were done.
no, we're not done yet. Have you ever been at a bar or somewhere and you want to impress your friends?
I sure have, Richard.
Well, you know what? You can impress them and teach them about the law of inertia.
Okay.
All you need is a bottle
Filled with water.
a bill, and some money. So all you have to do is take your bill, place it over the mouth of the bottle.
Oh, I have a question. How can we get those loonies into the bottle?
I'm gonna tell you a trick, okay?
Okay.
I want you to just slap your finger as fast as you can down. You should wet your finger a little bit just to get it so the bill sticks.
Oh, yeah!